Problem 7. We're given a square with side length 10 and a circle that's centered at one of its vertices with another radius of 10. So if this is a square and I have side length of 10, then this side length is the same thing as one of its radiuses, especially when the circle is centered at one of its vertices right here. So if I were to draw out this shape, then it must have 1/4 of its area, being the circle, being within the square. So if I were to have a rough drawing like this, it should serve our purposes. And I'll just make it a little bit more normal just for a good visual. So that looks about right. So this would be our shape. Given this shape, we know that the area of the union is what we're trying to solve for. So what is the union of two figures? Well, if I have figure A union figure B and I make it two circles, then the area will be this entire area right here. So we're basically trying to find the area of this entire region right here. So how do we do that? Well, first let's find the area of the square. The area of the square will be equal to 10 squared, which is 100. The area of the circle will be equal to pi r squared. In this case, r is 10, so r squared will be 100. So this will be 100 pi. Sum them up and we'll get the area of this entire shape plus one additional quarter circle. Why is that the case? When I first add the area of the square, I get this black region right here. But if I add it a second time with the area of the circle, I get this area right here. Notice how the green lines intersect with the black lines, particularly within the quarter circle. So we overcounted it by 1. So we must subtract out 1/4 of 100 pi in order to get rid of this green line within this region. That way we only counted it once, that way we will have a correct answer. So sum them up and we will be done. 100 plus 100 pi minus 1/4 of that, which is just 75 pi, or rather 25 pi. So 25 pi subtracted from 100 pi would give you 75 pi plus 100, which is simply answer choice B, and we are done.